Morning, students. Morning, everybody.
Hello, sir. Hello, sir.
Hi,
All right.
sir.
So we're ready to start the statistics today. Let's see, a little bit late, but no worries. Still gonna do this thing. All right. So ready for statistics. So let me just come off camera and get started right away. All right. Let's do this. Let's do this thing. All right. All right, guys. So the topic is statistics. It's gonna take us maybe 2 weeks to get through the notes, and maybe another week of practice and stuff. Now, statistics is kind of longish, because there's a good amount of material to cover in statistics. And the thing is that there are really three aspects to the statistics that we're going to be looking at. 3 methods for each thing. So we're going to be dealing with statistics of raw data. We're going to be doing statistics of ungrouped data and statistics of grouped data. And while they are all similar, there are some good differences between them that we have to note and pay attention to. All right. So I know a lot of you would have done this topic before, right? But I want to ensure that at the end of us doing it together, there are some nuances, some minute details that you will get. All right. Very important. So I wanted to focus on everything that we do. So today we're going to be focusing on statistics of raw data. And then maybe tomorrow we'll get into the ungrouped data and phase ourselves into the grouped data. And we're going to look at the reasons for the approach of each type in terms of the statistics that we use based on the type of data that we have, quantity and the nature of the data that we have. The statistics are the methods that we use for the various things will be different. So to calculate mean, for example, is not the same method you use all the time. It all depends on the data that you have, right? It depends on the data that you have. Same thing with median, same thing with mode, same thing with the range, interquartile range. So some of these things that I'm mentioning now, because I know that a lot of you would have done this topic before and will be familiar with these terms, and they would have also maybe experienced or been exposed to some of these terms when you were in prep and primary school, right? But there are some nuances, some differences depending on the type of data that you have. And in some cases, you can calculate the exact value of these things. And in other cases, you're only able to estimate the values depending on the data that you have. And you have to know the reasons or the reason why you can only estimate. CSEC will ask you that. Why are you only able to estimate the mean instead of giving an exact mean, for example? Why is it you're only estimating? Right? So when we get to those things, we deal with it. But statistics, what is statistics really? So looking at textbook, that maybe that's what you maybe see in a textbook. Statistics is a science. It is a science of collecting and analyzing data in order to draw conclusions and make projections. Right? So for example, they might use statistics to try and predict who's going to win an election. They use statistics in businesses to plan what they're going to do, from year to year, from one year to the next, to make projections. They use statistics to draw conclusions of things that have happened. And so something happened, you look at the statistics and you decide from the statistics help you decide what happened, why it happened, why it happened. They draw a conclusion, right? That is statistics, and the science is a study in itself, because there, Jamaica has a statistics institute, and there are professionals out there that they offer statistical services that are centered around statistics, which really is about like doing surveys. So for example, a company might do the survey about which radio station is the best, most listened to radio station, which TV station is what demographic of the population watch CVM versus TVG. There are companies hire these statistics institutes, statistics companies, to do surveys, gather data, study the data, draw a conclusion, so that companies can make plans and project and predict and decide, for example, if they want to go in a business, if they want to launch a new product on the market, all these things. The statistics play a significant role in our everyday life, right? So don't just view this thing as just mathematics you're doing in a class. It can be related in a lot of ways to everyday life. And what they'll do in the questions, they set the questions in a way that they relate to everyday life. So get familiar with that. All right. So the raw data collected may be arranged in an ordered form so that a frequency table may be prepared. So most times when you collect the data, there's no set order or there's no set pattern of collecting the data. So the data is random and all over the place. But what you want to do in order for you to analyze the data, right, you need to put the data in some form of order. So normally you put the data in ascending order, for example, or I might put it in descending order. And a lot of the times what they do, you put it in a table, so that from the table now you can analyze the data. All right, so and that table that they put the data in is called a frequency table, right? Because usually statistics is about counting how many times an observation is made. A lot of the times that's what it's about, how many times an observation is made, and that is your frequency, and that's why we talk about a frequency table. All right, so the frequency table is then used now to draw statistical diagrams. And the statistical diagrams, they give a visual representation of the data collected and aid in the final decision. So for example, let's say somebody get some data, they're running a statistics to try and determine which party is going to win an election. Say the JLP or the PNP. But everybody know the JLP color is green and the PNP color is red. And you get all these numbers, and you can put all these numbers in a table. But somebody looking at the table and they look at the numbers on the table might not actually glean which way the election is trending or the results are trending. But if you take that data and you represent it on a graph, a bar graph, for example, or you put it on a map of Jamaica, and all the places where JLP is likely to win, you color those places green, and all the places where PNP is likely to win, you color those places orange. Then somebody, instead of looking at the numbers, can just look at the diagram, right? And if it's a bar chart, for example, the one with the tallest bars, the one with more bars taller than the other, is the one likely to win. If it's a map of Jamaica where you shade it in orange and green, the one which has more orange, or if there's more orange than green, then it is basically saying that the PNP is likely to win. And if it is more green than orange, then it is saying that the JLP is more likely to win. And that's the importance of diagrams, statistical diagrams, pie charts, bar charts, line graphs. They give a visual representation of the data, because a lot of the times it is harder to see what the data is showing by just going by the numbers alone. So that's why the statistical diagrams are important. They give a visual representation of the data and helps you to understand the data, right? And aids in the final analysis. Some of the diagrams that we'll have to understand, draw from scratch, and interpret data from in this course, in statistics at this level. These are some of the diagrams: bar charts, pie charts, line graphs, histograms, frequency polygons, and the cumulative frequency curves. These are the 1, 2, 3, 4, 5, 6 diagrams that we have to understand, read information from, or we have to be able to go from a table of data or from a set of data and draw these diagrams. And after we draw these diagrams, we have to read information, make conclusions from the diagrams. That's how the questions are set up. You have to know which diagram is suitable for which set of data. Which diagram? When do you use a bar chart? When do you use a pie chart? When is a line graph suitable? When is a histogram suitable? When is a frequency polygon suitable? When do we need a cumulative frequency curve? You have to know when you need each one. And as I get to them, I'll say at the time. All right. So basically, this page summarizes sort of what we're getting into. So the types of data. What are the types of data? So there are basically 2 types of data that you can collect. You can collect what we call discrete data. So discrete data really is counting data. Data that you have to count, how many this, how many that. That is discrete data, data that you're counting. And they are usually of a definite value, like 10. The result is like 10 of this, 10 trees in the yard. One school has 500 boys and 200 girls, and another school has 600 boys and 300 girls. So you can count it. Counting data, that is discrete data. You have to know these things, guys. CSEC asks these things on multiple choice, sometimes on the paper too, the squeeze in a question. Discrete data. And the statistics for discrete data is different from the other one, which is, so like, for example, so there's some examples here. Number of children in a family, you count them, you're counting. Distribution of shoe size, you know, so shoe size is only go like half size and whole size. 7, 7.5, 8, 8.5, 9, 9.5, 10. You're not going to see a shoe size 7 3/4. Shoe sizes are set. And so you can count how many size 7s you have, how many 7.5s you have. Definite values. Then the other type of data that you can have is continuous data. So continuous data is data that you have to measure something. Measurement. And the continuous data, therefore, can be of indefinite value because you're measuring something. Like you might measure the weight of persons. You can be measuring time. How long does it take to do something? And just like how in track and field, for example, you can say somebody run the 100 meters in 10 seconds. If you go into the nearest whole number, or you can say 9.6 seconds if you go into 1 decimal place, or you can say 9.58 seconds if you go into 2 decimal places. And if 2 persons run the same time to 2 decimal places, what they usually do to break the tie is that they go to the 3rd decimal place to break the tie in terms of the time. Right? If 2 persons have the same time, 9.58, 9.58, they might say, okay, let's go to the 3rd decimal place. 9.581, 9.582 to break the tie to see which one of them really passed the line first. They go to the 3rd decimal place, right? And so that's why we say it can be of indefinite value. Definite value like 1, 2, 3, 4, 5. Indefinite value is measurement value. So continuous data is data that you have to measure. And we're gonna see when we start doing the statistics some more why the data is called continuous. Because what happens is that the data continues from one range of value to another range of values. One range of values to another range of values. It continues seamlessly. Right? And when I get to that stage, I'll explain to you at that stage why the term continuous is useful. Right? And it usually comes in measurement data and when the data is grouped. Continuous data, but generally speaking, measurement data is continuous data. All right, so for example, the height of persons may be 158 centimeters if you measure into the nearest whole number. height of a person might be 158 centimeters. That's if you're measuring it to the nearest whole number. But if you're measuring the same height of that person to one decimal place, then to be 157.9. And if you want to be a little bit more accurate, for the same person, they might use instead 157.94. And all that depends on the level of accuracy that you want. That is continuous data. So it's not definite, they are not definite values, because it all depends on the level of accuracy that you want. And it's measurement data, continuous data. All right. Frequency. What is frequency? Frequency is the number of times an observation is made. That's what frequency is. The frequency is always a whole number. You're counting how many times something is observed. The frequency is always a whole number. 10 times, 5 times, 50 times, 13 times. Always a whole number is a frequency. There are times we're gonna get into like 5.5 times or 3.5 times of something, but we explain the significance of those when the time comes. All right, but generally speaking, it's a counting number of times. Number of times is a counting thing. So it's 1, 2, 3, 4, 5. So the number of times an event occurs or an observation is made. All right, so you're taking statistics, and it's all right. How many times somebody measures 6 feet exactly? Maybe 10. That means that there are 10 persons who measure 6 feet. So the frequency of the 6 feet measurement is 10. All right. Let's look at an example here still. It says the result of a die toss 10 times. You toss a die 10 times, same die. You toss it 10 times, and these are the results. You toss one die 10 times, and these are the numbers that they get on the die. Remember, a die can give you between 1 and 6. Right? A die can give you values between 1 and 6. And those are the values. Right? So the frequency of 1 is 3. The frequency of the 1 is 3. So the one here, 1, 1, 1. 3 of them there. So the number of ones is 3. So 3 of the tosses were ones. So the frequency of 1 is 3. So you're doing the information, frequency of 1 is 3. If you were to put on a table, in the frequency column beside 1, you put in the number 3 there. All right, so far so good, guys? But okay so far?
Yes, sir.
Yes.
Yes, sir.
All right, I know this is easy stuff for now. I know a lot of you learn these things already. All right, so we're gonna do statistics of raw data today. All right, statistics of raw data. What I did just now was just like some background. We're gonna go into the statistics now, and my focus is to just deal with raw data alone today. All right. So when do you have the need for raw data? You use statistics of raw data when the amount of data collected is very small. You have a very small number of data, and you can just line them out in a line out the data in a line and analyze them. So like maybe up to 10 pieces of data. You can analyze the data in a raw state. That's what this is saying. So when the amount of data collected is very small, it may be analyzed in the raw state. You don't need to put it in a table. You can just list out the values side by side and analyze them easily like that. That is raw data. And so the method that we're going to use for statistics of raw data is one where we line them out, put them in a straight line beside each other and analyze them. But one step that is critical and very important in analyzing raw data, and it is the premise on which a lot of the statistical measurements that we're going to be doing, the mean and the mode and the median in particular, and the range and the interquartile range. It depends on the data being arranged in ascending or descending order. So put the data either in ascending or put them in descending order. What do I mean by ascending? Ascending order means that you put the lowest value first, and you gradually put in the values until you get the highest value last, in ascending order. If you're putting them in descending order, you put the highest value first, and then you gradually put in the values lower and lower until you get to the lowest value. So you want to put the data in ascending order or in descending order before you try to analyze it. Do not try to analyze raw data unless you put them in ascending order first. Some of the statistical measurements that you're going to do with raw data, you don't really need to put them in ascending order, you know? But it is good practice to put them in ascending order because some of the things that you're going to do with the data requires that they are in ascending order. So it sort of makes sense to just always get into the habit of putting the data in ascending order anyway, whether you need to or not. Because in some cases you need to, other cases you don't, but still get into the habit of putting them in ascending or descending order. And normally we put them in ascending order. We don't bother with the descending. We normally just put them in ascending order. All right, but there might be occasions where you might need, where you might choose to put them in descending order for one reason or another, depending on the data, depending on what it is that you're measuring, or depending on the question. The question might force you to put it in descending order. But if given you the option to make for yourself, generally speaking, we go for ascending, smallest to largest. All right, so and most times statistics is arranged that way, from smallest to largest. All right, so that's it. The data must, however, be placed in ascending order. Now, remember, I said you can go for descending, you know, but I'm working with the ascending in our class because I've never seen a question in CXC where descending order was pushed or forced on you. It's always that you can put it in ascending order. So I'm saying we're going to put our data in ascending order and say the word must. We must put them in ascending order, means from smallest to largest value. And we do that before we analyze it. Don't do anything until you do that first. Always make sure that you put them in ascending order first. All right? That's very important. So as an example, so let's say you collect that raw data. This might be the height of some person. How many persons we're measuring? Measure the height of some person. 1, 2, 3, 4, 5, 6, 7, 8. So measure the height of 8 persons in centimeters to the nearest whole number. And these are the measurements of the persons, 8 of them. It is random. Because I didn't line them out first in order of their height and then measure them. You just call them randomly and measure them. And these are the 8 measurements that you got. And you want to put them in ascending order. So you put the lowest one first, then the next one, and you can see now the data in ascending order. So this is what you would analyze. Throw away that, analyze that. But get me? But understand that?
Yes, sir.
Everything important. We're going from basic right up. Everything important. We're not taking anything for granted. So even a simple example of how you put data in ascending order, I'm giving an example. So you can see it. It's very important, guys. Don't forget this. See? Must. Don't forget it. Must. Sometimes in the exam when you're rushing and you see the values and you're just rushing fast and you forget the most important thing. The data must be in ascending order first. Don't do anything until you put it in ascending order. All right? All right, so what are some of the things we're going to be doing with the data now? After we put it in ascending order, right? What are some of the things? I use, as I said, the small amount of data that you have, like maybe up to 10, maybe up to 12, just normal data that you can line out side by side. You can put the values side by side, and then not too much. Maybe if it's 20, you're going too far, you're going to take up the whole page. You know, you don't really want them. I put that in a table. But usually like up to 10, 12 pieces of data, you know, you can put them in ascending order. But the question will more than likely give you the data in ascending order. No, not raw data, I mean. The question will maybe give you the raw data and ask to analyze it. If it's a ungrouped data, they will give you the ungrouped data. So they will sort of lead you to determine which one you are using. Right? But I want still you to understand, right, the importance of keeping the data in a raw state. If it's a small number of data, you don't need to put a table. We only have one value of each, for example. You only have 154 and 155, 156, 157. You don't even have any other values repeated here right now. So you're not going to put a table for this. And there's only 8 pieces of data. So just leave them as they are and analyze them. See me? All right? All right. So we say now, what are the measures? What are some of the measurements that we're going to be taking from the data? We call these measures of central tendency. Measures of central tendency. What's a measure of central tendency? The measures of central tendency are the mean, the mode, and the median. So the mean is a data, the mode is a data, and the median is a data. And you get them from the original data. These are values that you calculate or determine. Sometimes you don't need to calculate, you can just observe it from the original data. And these are called measures of central tendency because they tend to be around the middle of the data after you put them in ascending order. These values are usually somewhere around the middle of the data after you put them in ascending order, right? They're usually close together in value, the mean, mode, and median, depending on whether the data is balanced or the data is skewed. When it is balanced, they say it is normal. It has a normal distribution if it is balanced. If the data can be skewed to one side, skewed to the left, or skewed to the right. Meaning, for example, over here, this example, you might have, instead of 163, you might have a very large value like 220 as the last value. So the data is kind of big on the right side. So it's drifting away from these. These values tend to be around the same, and they have this big one out here, right? So in that case, that one figure, they start showing out the symmetry, if you like, of the data. And in another case, you might have a value down here that is very small, like you might have a value where it's 99. First value is 99. It's just way below these, too far, like it's just uncharacteristic, that 99. And so the data is not balanced. It's not normal. And so in that case, now the mean and the mode and the median might not be close together in value. But when the data is close, when all the data values are close together relatively, and the change along the data is sort of same, sort of balanced. You don't have any value too large or too small. And these values are too large or too small relative to the rest of the data. They are called outliers. Outliers. Then what will happen is that the measures of central tendency will tend to be around the same. Around the same. For a perfectly normal distribution that is totally symmetrical, same number of small values, same number of large values. So like you have the small values over here, I have the large values over here. I have the same number of small values and same number of large values. And then the small values, the difference in the small values is basically the same as the difference in the large values. Then the data is normal, symmetrical. In that case, these three values will be the same. The mean, the mode, and the median will be the same. I will more than likely be the same. That's the greatest possibility that they'll be equal to each other in value when this data is normal. But you all have what we call a normal distribution. The distribution is usually skewed to the left or skewed to the right, somehow. Normal is not normal. And so those three values usually are not equal. Right? But what happens is that you use one of these values when you're trying to find one value from the entire set of data to represent the data. So like, for example, you have the height of the person over on the previous slide, over here, right? You might want to find one value to represent all of them for whatever reason. Whatever the reason is, you might want one height that you can use to represent all of them, right? All right, suppose this was a competition, for example. I don't know if you ever watch like some competition, like the Winter Olympics going on now, and they have figure skating going on and all these things. I might have 8 judges, and the 8 judges give a score to a competitor. What happens is that they want to give that competitor just one score, So they find some way to use those 8 scores to determine one score. So they might decide to use the mean, they might decide to use the mode, they might decide to use the median, they might decide to get all the outliers and then use the mean of the rest, some method they use. to come to those one score. They want one score to use to represent the data, right? Without those gymnastics with the data, the one score that is normally used is either the mean, the mode, or the median. So these are values that are used to represent the data, right? That you can use to represent the data.
Sir, what is the median again?
The median, I'm going to come to it, you know. I'm going to come to each one, but I'm just discussing them first. So the median is the value in the middle of the data that is already ascending, such that you have the same number of values below it as they are above it. But I'm coming to it. But I just want to understand that these are values that are used. It's one value that they will be, and it is when you want to use one value to represent the data. And then the one that you use depending on the reason that you want the one value, and also depends on the nature of the data. Right? The one that you use depends on the nature of the data. And I can give you some examples soon. So sometimes it's better, for example, to use the mean. Sometimes it's better to use the median. And sometimes it's better to use the mode. All depends on the situation and what you want the data to represent. All right? We can look at an example just now, but let's look at what I'm saying on the slide. So these are statistical averages. So they're all called averages that are calculated or determined. I put the word calculated there, but it could be also determined because some of them you don't calculate actually. Right? Not every time you have to calculate. Because the mode, for example, you don't need to calculate the mode. And the median, a lot of the time you don't need to calculate the median. The mean maybe is the one that you always have to calculate. Right? When there is the need to find or use one single value to represent the entire set of data. So when you want one value to represent the entire set of data, use one of these. And as I said, no, the one that is used depends on the conditions. The one that you use depends on the conditions. All right? The one that you use depends on the conditions. All right. So let me give an example of just a quick example of when you might use the mean versus the mode. Yeah, give a versus the median, for example. Yeah, look a quick example. If you can come with an example fast. So let's say we have some data. 10, 20, 30, and then we have 100. So these are 4 scores that I'm analyzing. They're supposed to be around the same number: 10, 20, 30, and then 100. All right. I'm put in another value, put in one more value. Let's put in 30, 40. And then we have 200. Instead of one, I put 200. So they are in ascending order. So those are my data. 1, 2, 3, 4, 5. Now, let's say these are test scores in a class. Let's say these are test scores in a class out of a mark of 200. All right. So one person get 10, one person get 20, one person get 30, one person get 40, and then only one person get 200. And let's say I want to know the standard of the class. I want to know, how well is the class doing, really, in this subject. If I go for the mean, what is the mean? The mean is calculated, and I'm going ahead of myself, but no problem, because I think you know them already. The mean is the sum of the values divided by the number of values. 1, 2, 3, 4, 5 values. Work it out for me. So the sum of the values 10 plus 20 plus 30 plus 40 plus 200 divided by how much?
5.
What is work out to?
60.
60, right?
Yes, sir.
60. So we are saying the mean of the class is 60. But when you really look at the scores in the class, the majority of the class actually score less than 60. And when you say mean, usually you expect a mean value to be such that there are around the same number of persons getting more than 60 as they are getting less than 60. Most times, that's what you expect, don't it? If somebody says, boy, the average of something is 60, They expect that, okay, some of the values are going to be less than 60, some are going to be more than 60. If some of the average is 60, let's say I have a basketball player and he's scoring basket, he's scoring basketball, scoring points in a game. I know some basketball player score 60, but let's use 60 as an example. And I say, okay, his average score per game is 60. You know that sometimes he's going to score less than 60 and sometimes he's going to score more than 60. But he balance out at 60. So he expects, all right, the number of times he score less than 60 is around the same as the number of times he score more than 60 for the most part, such that him average come to about 60, come to 60. But if you look at this class with these 5 students, 4 of them actually get less than this mean. So it is not true that the mean for the class is 60, really, when you have the majority of the class getting actually less than 60. So in this case, using the mean to represent the class is not a true reflection of the performance of the class, because you really only have just one outstanding person that brought the average up to 60, the mean up to 60. So in this case, you wouldn't want to use 60 to represent the performance of the class. 60 would not be a true representation of how the class is doing, because the majority of the class is actually getting less than 60. So this is an example where you want to go, maybe go for the median and maybe go for 30 and use median instead. So the median score in the middle is 30. And this 30 means that there's an equal number of persons getting less than 30 as there are getting more than 30, which is true. This will be true of the data. But this will be false. This will be falsifying the data somewhat. False. It is only became 60 because of this outlier. This is an outlier value. That person getting 200 is not characteristic of the rest of the class. So the 60 is not a true representation of the performance of the class. So if you want a 1 score to represent what? The performance of the class, 60 would not be a good score to represent the performance of the class, because the majority of the students getting less than 60. You understand that example, guys?
Yes,
Yes,
sir.
Understand the reason? Good. So that's an example of when you might want to choose one over the next. If all the scores work on at the balance now, the mean would have okay. So if the next person up here then maybe get 60 up here, so let's say the last person instead they get 60. Or I say 50. And this would have 50. Where this out for me again now? This would have 50. Then what the mean would have been now?
30.
The mean, huh?
30.
30. So you see, in this case, it balanced because the mean and the median are the same. So in this case, it's okay to use the mean this time. It's okay to use the mean. The mean this time is a fair representation of the performance of the class. You understand me? So there are times where you don't want to, and it's usually when you have outliers, you don't want to use like the mean, and the median becomes better. Because the median kind of eliminates the outliers, the effect of the outliers, the very large values and the very small values. All right, let's continue though. I think I went ahead of myself a little bit, but that's how it is sometimes. That's how mathematics is sometimes. What comes first, the chicken or the egg? So we're looking at arithmetic average now. The mean is the arithmetic average that we're all used to. So the traditional way of calculating average, they are all called averages, you know, all of them. They are all called averages. All of these are called statistical averages. But the mean is the arithmetic one. The arithmetic average is the mean, the one where you add the values and divide by the number of values when the data is raw. So this thing just means sum of. I think I have it on the slide. Right? So this symbol, this is a symbol for sum of. This is a symbol, this sigma, it means sum of. It means sum of. As a symbol for sum of. So therefore, this is the sum of x, which is the sum of the values, divided by the sum of the frequency. The sum of the frequency is a number of values. the number of values or the number of observations. So that's a formula for calculating mean. And mean, you put a bar on the x. X bar is a symbol for mean. So the mean from raw data is equal to the sum of the values divided by the number of values. Simple formula. All right, and when we calculate mean at the other statistical levels, it basically stem from this. They're going to stem from this. They're going to be modified, but still stem from this or connected back to that. Just that the data is raw, so you just add up the values and divide by the number of values. So the values are 1, 3, 5, 7, and 11. If that's a set of data, and you want to calculate the mean, you simply add them up. It's 5 of them, you divide by 5. And so the mean will be 27 over 5 or 5.4. And let me show you something, it's very important. The mean, mode, and median must carry the same unit as the data. Same unit as the data. Same unit as the data. Very important, this thing. Shall put it on the slide from before. So if these are in centimeters, for example, 1 centimeter, 3 centimeters, these are all in centimeters. Let's say these are all in centimeters. All of these are in centimeters. Then the final answer, which is the mean, must also be in centimeters. The mode is going to be in centimeters. The median is going to be in centimeters. People tend to leave off the unit when they calculate the mean, mode, and the median. Don't get into that habit. You must put the unit. Whatever the unit the original data is in, all the measures of central tendency and also the measures of spread, all the statistical measurements must carry the same unit as the data. Measures of central tendency, measures of spread, we're going to look at next. They must carry the same unit as the data. So get into the habit of writing the same unit. All right? Everybody good so far? We'll move on. Everybody okay?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
All right, good. So moving right along. The next one is mode. Everybody must know. Mode is the data with the highest frequency. The data that occurs the most often. Right? The most frequently occurring data is the mode. And it is a data. It is a score. Important thing to remember that the mode is not the frequency. The mode is the score with the highest frequency, not the highest frequency. Right? So the mode is not the frequency, guys. That's a common mistake people make all the time. The mode is not the frequency. The mode is the score that has the highest frequency. So you find the highest frequency and find the score that matches that highest frequency. When we come to data on tables, it will become more important for us to recognize that. Right? But the mode is a score. It's a score that occurred most often, most frequently. And in raw data, you'll be able to see it. Okay? Just look for the data that occurred more than the rest, more often than the rest. That's all you have to do. Right? So the data can have one mode, it can have 2 modes, it can have 3 modes, and so on. But you usually don't find data with more than 3 modes, but it can have. And in fact, at CSEC, I've never seen them set a question with more than 1 mode. It's always 1 mode they give at CSEC. But it can have 1 mode. It can have 2 modes, it can have 3 modes. Right? If it has 1 mode, which they usually do at CSEC, then it is called a unimodal. If it has 2 modes, then it is called bimodal. If it has 3 modes, then the data is said to be trimodal. All right? But most times it's just this again, unimodal. Most times it's just this again. So I wouldn't worry too much about the 2 mode, 3 mode. But just in case, you know, you're familiar with the terms, just in case something pops up. It might pop up at advanced level, right? Where the terms might become more relevant and useful. But at CSEC, no, they usually just give unimodal. But I'm not going to tell you to ignore these things, everything important. Right? So you might not doing a question and see bimodal or trimodal come into play. But I still wanted to be familiar with the terms just in case. I never know that what I might ask in CSEC. All right, so be familiar with them still. All right, so in this set of data given, what's the first thing we need to do, guys? So we get this set of data to analyze. What's the first thing we're supposed to do with it?
Sir, I read it in ascending order.
Put them in ascending order first. Very good. Always the first thing you have to do. But the mode is 4. You can look at that and say the mode is 4. But if you wanted to analyze it, you put it in ascending order. But the mode is 4, because 4 is the score that occurred most frequently. Look at this data now. What is the mode in this table? What is the mode in this table?
So 0.
5.
All right, so look at the table, good. Somebody says 0, somebody says 5.
Sir, 5, sir.
5.
All right.
Sorry.
Okay, so remember, the mode is not a frequency. The mode is one of these. The mode is a score. The mode is a score. I emphasize at the beginning now. The mode is the most frequently occurring observation or score, not the frequency. The mode is not the frequency. So the person who said 0 is giving me this frequency. The mode is not a frequency. The mode is a score. So what you have to do, you have to find the highest frequency, which is this, and find which score matches that highest frequency. Right? And the score that matches the highest frequency is 5. So the mode is 5. In other words, 5 occurred 10 times. 5 occurred, this 10 means 10 times. 10 times you have 5. So 5 is the one that occurred the most frequently. All right? So that's that. That is the highest frequency. The mode corresponds to the highest frequency. And so the mode is 5. The mode is 5. So see there now, note, the mode is the score and not the frequency. And notice I put the centimeters on it. I put the centimeters on it because the data is in centimeters. So the modal length of a stick is 5 centimeters. Plenty people tend to leave this off and just put 5. I don't want my students to do that. Put the score, put the unit of the score on the data. But as mean, mode, and median you're finding, always put the score, the unit of the score on the value of the mean, the mode, or the median. All right, so we did mean and we did mode. The next one now is median. Median. And the symbol for median is Q2 because it represents what we call the second quartile. We're going to look at the quartiles shortly, but Q2 is a symbol for median because it corresponds to the second quartile or the middle quartile. We're going to look at quartiles shortly. All right. So this is the one that you absolutely must put the data in ascending order for. This one. Must. So if you forget to put it in ascending order for the mean and for the mode, you cannot forget to put it for the median. You absolutely must put it for the median in ascending order. All right. So see you know, this is the middle or central value, the one in the middle. Right? Of a set of data in ascending order, ascending observation, of a set of ascending observation. All right. The mode will therefore have, the median, so will have the same number of values above it as there are below it. So when you find the mode in the middle, you might have 10 values over here, so, and you're gonna have 10 values over here, so. You must always have the same number of values to the left and to the right of the mode, of the median, I mean, Jesus, Q2. You must have the same number of values in there. So therefore, if you're gonna have the same number of values above and below it, the total number of values must always be odd, an odd number of values in the end. You must have an odd number of values if you include the median. So the question is, what do you do if they give you an even number of values? If they give you an even number of values, you have to add the median in the middle. and you add the median in the middle to make it odd by taking the average of the two middle values. But you must end up with an odd number of values in the end, including the median, because you must always have the same number of values that are less than the median as they are greater than the median after you put them in ascending order. Very important. You must always end up with an odd number of values, including the median when you're done. All right? If they give you an odd number of values, then one of them is the median. If they give you an even number of values, you have to go add another value to make it odd. And you add the average of the two middle values. The average of the two middle values will become the median value. All right? All right, so the median will have the same number of values below it as they are above it. And that's why I said the total will be odd, including the median. So when there's an even number of values, the average of the two central values is taken as a median. So you're adding a value in the middle. So if I give you 10 values, I give you 10 values across. 10 values across. Right? What you have to do? I will divide it 5 and 5 and inject one in the middle. 2, 2. I will divide it 5 and 5. 5 below, 5 above. And in the two middle ones, I take the average of them and put that one in the middle to make it now 11 values. The 10 original ones and the average one in the middle. If they give you an even number of values, you have to divide the 5 and 5, but the two middle ones, you average them and you inject the median in between. So you must always end up with an odd number of values, including the median, when you divide up the data. So look at this data now. I want to calculate the median of this data. First, you want to discount how many values are there. 1, 2, 3, 4, 5, 6, 7. But before you count them, there's something more important to do. What is it?
Sir, arrange them, sir.
Good. Ascending order first. All right. So after ascending order, we'll count them. 1, 2, 3, 4, 5, 6, 7. So since that's an odd number of values, means that one of the values is the median. Right? The one in the middle is the median. So if there are 7 values, then the one in the middle, that must be the median. So you have 3 below it and 3 above it. 3 below it and 3 above it. Right? There's actually a formula way to calculate the position of the median, but we don't reach there yet. Right? We don't reach there yet, but that is it. So that's it. You have 3 below the median and 3 above the median. But some people do, they count from the ends to find the median, right? Some people would like this. There's a lot of data, and it's obvious. They count from the end. So that's all right. 1 for 1, 2 for 2, 3 for 3, and let's say this one left. The count of the end ones. See it? That's this one balance with that one. This one balance with that one. This one balance with that one. So they equate out the ends first, and the one that end up with in the middle becomes the median, Q2. But you have to have an equal number. You have to have an equal number of values below and above the median at all times. All right, and that's it. Q2. Bottom half, top half. And the median is Q2 158. All right, so we're going to give it that now. How many values are there? Ascending order first, right? So they give us, in this case, it is 1, 2, 3, 4, 5, 6, 7, 8. An odd number of values. It means we'll add one in the middle to make it 9. We'll put them in ascending order first. All right, so I think sometimes it's easier when they give an even. I don't say just divide half and half straight. But anyway, not an issue. So put them in ascending order first. You know, so you're going to add a value to the middle. So you divide it half and half, 4 and 4. And you add one in between them to make it an odd number of values. And you're adding the average of the two middle values. Average of these two middle values, putting the average between them. So the average of 156 and 158 clearly is 157. Clearly is 157. So the median Right in there, you add it. It's 157. But I go so far?
Yes, sir.
Yes,
All
sir.
right. 1 second, 1 second. Oh, 1
Yes,
second.
sir.
Stand by down. Oh, stand by down. Oh, all right. Stand by something. Oh, yeah, some something today. All right, guys. Sorry about that. Have you know the container coming? Okay. No, not the container, the pallet. Checking for me now. No matter how far the lady is now after 12 already. All right, guys. Sorry about that. All right, so far so good, right? So far so good. All right, so let's move on. Let's move on. So top half, bottom half. Now this top half and this bottom half, they're gonna become important when we start to do the measures of spread, you know. Measures of spread. All right. So the median is 157. And again, if the data is in centimeters, the median must be in centimeters. If the values are in kilograms, the median must be in kilograms. The statistical averages must carry the same unit as original data. All right, because remember, these are single values that you're using to represent the entire data. All right, so let's continue. Then we'll come to the measures of spread now. Measures of spread are the measures of dispersion. What are these measuring now? So the central tendency is when you want to find one value to represent the data, and it's usually a value in the middle of the data, or near the middle of the data. So the measure of dispersion or measure of spread really is about analyzing how the data is spread out. That's what the word spread is there. How the data is distributed. How far from the mean does the data go left and right? How far from the median does the data go left and right? How far from the mode is the data going left and right? It's a measure of how the data is spread out. Is the data close? Are the data values close to each other? Or are the data values wide from each other? That is what the measures of spread is measuring for the most part. How wide is the data? Right? That's what measures of spread is calculating. Are the values close? Are the values wide? And so on. I don't have standard deviation on this slide, but standard deviation came back onto the syllabus after I prepared this slide, but we are going to talk about standard deviation. And what it is for standard deviation is that they just want us to learn to analyze the values or compare standard deviation values. But standard deviation is another measure of spread that we're going to talk about. It's just that it's not on this slide, but we'll talk about it. All right. So the three that are on this slide are range, interquartile range, and semi-interquartile range. And as I said, no, there's another one that they call standard deviation. Standard deviation. Deviation, which we're going to talk about. And at CSEC level, they don't want you to calculate it. At AdMath, students have to calculate it. With CSEC values, CSEC students, they give you like two standard deviation values. Like so standard deviation is 6.2, and another standard deviation is 8.5. And I want you to interpret the 6.2 versus the 8.5. What does the 6.2 mean versus the 8.5 if you're comparing data? So one set of data have a standard deviation of 6.2, and another set of data have a standard deviation of 8.5. What does that mean? How do you compare the two sets of data from the perspective of standard deviation. We're going to look at that soon, all right, or eventually. But what is range? All right, firstly, these are the measures of how the data is distributed around the central tendency, the mean, the mode, and the median. All right, the standard deviation is always in reference to the mean. So when we talk about standard deviation, it's going to be always in reference to the mean. The comparison of how the data is spread out around the mean. A standard deviation, SD, standard deviation, is comparing how the data is spread out around the mean. But generally speaking, measures of dispersion is basically testing or analyzing how the data is spread out around the central tendency, the mean, mode, and the median. That's what these things do. All right? That is how closely or how widely spread the data is. The measure of the data, are the data values close together, or are the data values wide from each other? Right? That's what these things measure. All right. So the first one is the range of the data. And we're talking about raw data still now. We're not getting into group data and ungrouped data yet. Because the definition is going to change a little bit when we come to group data and ungrouped data. The method and the calculation is going to vary a little bit. But each thing that we did so far now, the mean, the mode, the median, now the range, the method that you use to calculate these things will be a little bit different next class when we start to talk about group data and ungrouped data. So everything here is just for raw data. So it's going to be very important for you to watch over the video and the videos when we finish all the types of data to make the comparison. How you do it when the data is raw, how you do it when the data is grouped, how you do it when the data is ungrouped, how you do it. What is the approach? What is the difference in the method? What is the difference in the approach? Why do we make this difference? Why do we use a different approach depending on the type of data? But for now, for raw data, the range is just the largest value minus the smallest value. That's what it is. The difference between the largest and the smallest value is the range. So if you have, that's it. Largest value minus smallest value. So if you have a set of data like this, right here, then the range is just the largest value, which is just 185 right here, minus the smallest value, which is just 148 right here. Largest minus smallest. And maybe that is another reason why, oh, you see, I marked the wrong one. See, the important I put them in ascending order because I marked the wrong one. It's 195, that is the largest. See it? That's why it's so important to put them in ascending order. Because if you put them in ascending order in a systematic way, they won't miss out any of them. All right? But anyway, that's it. 195 minus 148. Right? So the range for this data is 47. And again, if this data was in centimeters, then the range is 47 centimeters. Must carry the same unit as the data. Very important. People tend to leave off the unit in statistics all the time. Let's not do that. If a unit is to be there, let's put it there. All right? Good and easy, right? Simple. Range is just the largest value minus the smallest value when the data is raw. When the data is not raw, the formula is going to be vary a little bit. It's going to be a little bit different. And I explain the reason for the difference when the time comes. All right. Interquartile range and semi-interquartile range. Now, what are these? So off the bat, these are ranges closer to the middle of the data. So I'm going to tell you quick, and I'm going to show you how you calculate them, right? So let's say you have some data represented by this line, these lines right here. I'm just using this to represent data. So you have the smallest data down here. You have the largest data up here. This is like a diagram to just like a diagram to illustrate the data. So the range as we just did, this is the full range, end to end. Difference between the smallest and the largest value. The interquartile range is a range closer to the inside. The interquartile range is a range closer to the inside here. This is going to be Q3. This is going to be Q1. I'm going to define Q1 and Q3 just now. But it's a range closer to the middle. So it's like you're Xing out, you're eliminating the extreme values. The extreme large values and extreme small values. It's a range that is closer to your mean and your mode and the median, closer to your central tendency. Remember, the central tendency is going to be somewhere inside here. Your mean, your mode, and the median. So you're taking a range that is closer to the middle. So that range now is a true reflection of the bulk of the data. Usually out here, you have a small number of data out here and a small number of data at the end. The bulk of the data is usually in the middle. And you want to find what the range of the data is closer to the middle. So you take the interquartile range. The semi-interquartile range is a range even closer to the middle. Even closer to the middle. I'm just represent it like this. So like you have this, and you have this, 790. And that is now your 7. Choose the wrong thing. Choose the wrong thing. Okay, can I erase? Let me see if I can erase them. Yeah, let's use this. Let's use the orange. Right, so like a range even closer to the middle is your semi-interquartile range. But at the same time, the word semi means half. So the semi-interquartile range, even though it's a range closer to the middle, it is there to represent a range closer to the middle. It is calculated by doing the interquartile range over 2, because semi means half. In mathematics, like semicircle is half of a circle. Right? Semicircle is half of a circle. So the same thing, the semi-interquartile range is half of the interquartile range. Right?
Sir,
So
how you find the interquartile range again?
and what is the difference between the Q3 and the Q1? I'm just giving a visual representation of what is that before I actually show the calculation. But I'll show you how you get Q3 and how you get Q1 next. So remember, the median is Q2, and then you have Q1 and Q3. I'm going to show you how you get those and what they are. I just want to give you a visual representation of what these ranges are before we get to that. So you have the largest value, you have the smallest value, smallest value at the end here, large value at the end here. The range is a full range from end to end. Then you have the interquartile range, is a range between the 2 quartiles, the upper quartile and the lower quartile, Q1 and Q3. So therefore, it's a range closer to the middle. And then the semi-interquartile range is a range of values even closer, even more close to the middle than the interquartile range. But to calculate that, you just take half of the interquartile range. All right? So the question is now, how do I get the Q1 and the Q3 that I'm using? See here, the interquartile range, you know, right? The interquartile range formula is Q3 minus Q1. Q3 and Q1 are the 3rd quartile and the 1st quartile. So the question is, what are the quartiles? I think that's what comes up on the slide first. Let me clear this and go. So a quartile is one of the 3 values that divides an ascending set of data into 4 equal quarters, 4 equal parts. So the values that divide the data into 4 equal parts, those values are called the quartiles. So let me draw back a representation now. So again, now you have a small value here and a largest value out here. This is just to illustrate what I'm talking about. And I want to divide that set of data into 4 quarters. 4 quarters. So first I'm going to divide it in half by calculating the median. Divide it in half, a top half and a bottom half. That is Q2. And so you have the bottom half and you have the top half. All right, so this is the bottom half and this is the top half of the data. If you take the median of the bottom half and divide the bottom half in 2 equal halves now, then that you find in Q1. And then if you take the median of the top half and divide the top half into 2 equal parts, like you take the median of the top half, then that is Q3. That's where you find the quartiles. So you see, you have divided the data into 4 equal quarters. 1, 2, 3, 4. The 3 marks dividing it are these: 1, 2, 3. The 3 scores divided in the data such that it has 4 equal parts. It's the 3 scores that divides the entire set of data into 4 equal parts. Those 3 scores are called the quartiles. All right? And to get the quartiles, you find the median first. That is Q2. And when you find the median Q2, you're going to have a bottom half and a top half. Remember, you know, you must have the same number of data in the bottom half as there are in the top half. Then what you do with the bottom half, you find the median of the bottom half. The median of the bottom half is Q1, and the median of the top half is Q3. And then the interquartile range now is between these two. The difference between those two is your interquartile range between the Q3 and the Q1. So Q3 minus Q1. So this equals Q3 minus Q1. All right. So that in terms of a diagram, that is what. So these 3 are your quartiles. Those 3 marks are your quartiles. So because there are 4 equal quarters, these 3 scores divide the data into 4 equal quarters. It means that 1 quarter of the data is below the bottom half. 1 quarter of the data is down here. 1 quarter of the data is down here, so. And they have another quarter inside here, so. Second quarter, another quarter of the data inside here. So those 2 quarters give you half. They have a quarter of the data up here, so. Inside right there, so you have another quarter inside here. 1/4, 1 quarter of the data. And then you have another quarter inside here, so 1 quarter of the data is up here. So if you look at it, you have 3 quarters of the data below the Q3. 3 quarters of the data is below the Q3. 3 quarters of the data is below the Q3 and 1 quarter above. So you can look at all the various combinations that you want. So 1 quarter of the data is below Q1, but 3 quarters of the data is below Q3, and half of the data is below Q2. Think you understand that, guys?
Yes,
Think you
sir.
understand that?
Yes, sir.
Yes, sir.
Beautiful. So see it here now. 1 quarter of the data is below the first quartile. 1 quarter of the data is below the first quartile value. So after I find the first quartile value, 1 quarter of the data is going to be below the first quartile. Then after I find the median, half of the data is below the median. I said that, then remember, half of the data is below the median. And then 3 quarters of the data is below the Q3. All right. So to find the quartile, what do we do? Step by step to find the quartiles. First, you find the Q2, the median. And when you find the Q2, what you do, you divide it now into a bottom half and a top half. You divide it, and you have a bottom half and a top half. Then you're going to find the median of the bottom half, which is Q1, and the median of the top half, that is Q3. Q1 is the middle of the bottom half. The middle of the bottom half is like you calculate the median again of the bottom half. So the same way how you calculate the median of the whole data is the same way you calculate the median of the bottom half, depending on the number of data that is in the bottom half. And Q3 is the middle or the median of the top half. The same way you calculate the median of any number of data That's what you calculate it for the top half. And then this is an example now. 1, 2, 3, 5, 6, 8, 10, 12, 19. That already is in ascending order. How many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So since there are 9 values there, one of them is the median. One of them already is the median. This one in the middle, that one. So you have 4 below, and 4 above. All right, let's mark it. That is the middle, Q2. Sorry about that, guys. Oh. All right, that's the middle Q2. And so we now have a bottom half and a top half. See them there? Bottom half, top half. Now, if you look at the bottom half, there are 4 values in the bottom half. And if we want to calculate the median of those 4 values, we're going to have to add a value. Because remember, you must always have an odd number of values. So the middle of the median of the bottom half, since there are 4 values, is going to be the 5th value in the middle. We've got to add a value in the middle. So you add that value between the 2 middle values and take the average of the 2 middle values. The average of these 2 middle values, you have add a value in there. That is 2.5. Average of 2 and 2 and 3 is 2.5. A value in between 2 and 3 is 2.5. Same thing happening up the top half. There are 4 values there. I want to calculate the median of those 4 values. The median of those 4 values on the top half is Q3. Since there are 4 values there, you must always have an odd number of values when you have the median. And so we have to go and calculate the median of that top 4 values, the middle of the 2 middle values, the average of the 2 middle values. All right? Everybody there with me still?
Yes, sir.
All right. So let's look at it. So I'm going to put a value in there, 2.5, and that is Q1. I'm going to put a value between the 10 and the 12. Clearly, that's 11. And that is Q3. So I have those values now. And from those values, we can now calculate the interquartile range, the range closer to the central tendency. It eliminates the extreme values at the end, and it's calculated Q3 minus Q1. That's what we said. And the semi-interquartile range is the range much closer. The word semi means half. So it's half of the interquartile range. So the semi-interquartile range is the interquartile range divided by 2. And so it's 8.5 divided by 2, 4.25. And basically that's it for that data. From the statistical diagram, I want us to do a couple more examples with some values to break up some values again. All right, so I'm going to continue with the same set of data that we had before, but I want us to do some more. Anybody go with that, those calculations so far?
Yes, sir.
Yes, sir.
All right, so let's do another example with some more values. How many values were here? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So let's say we put in another value. So we have 1, 2, 3, 5, 6, 8, 10, 12. Let's make that a smaller. I'm gonna put by the 19, but I'm not gonna put 21. Put in one more value. That's what the difference is gonna be. Put in one more value. How many values are there now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 values there. We need to add a value to the middle, don't it?
Yes, sir.
You have to add a value to the middle. You must have an odd number of values when you finish putting in the median. You must have the same number of values below and above. So I divide the 5 and 5. 1, 2, 3, 4, 5. Bottom half. 1, 2, 3, 4, 5. Top half. So clearly, in the middle here, you have to put in
7.
Q2, which
Oh.
is 7. Beautiful. Yeah, man, 7. Q2 is therefore 7. the average of these two middle values is 7. But I agree with that.
Yes, sir.
Yes, sir.
And then now, with these bottom half values, there are 5 of them. So since there are 5 of them, one of them is the middle. Which one is the middle? Which one is in the middle of these bottom half?
the 3.
The 3. So the 3 becomes a Q1 this time. So you don't have to calculate nothing. That is the 3, Q1. And then at the top half, there are 5 values there as well. And so one of those values, since an odd number of values, one of those values is the middle of the top half. Which value is it?
12.
12 is your Q3. 12 is a Q3. And so since we know them, we can calculate the interquartile range is a Q3 minus the Q1, which is the 12 minus 3, which is 9. And the semi-interquartile range is the interquartile range divided by 2, which therefore becomes 9 over 2, which is 4.5. So far, so go to that example.
Yes, sir.
All
Yes,
right.
sir.
Yes, sir.
Let's see if we can do another one. Let's put in another value and see how it differs. Let's go again. Copy. More maths equals better maths every time. Let's do another example right here. So I'm going to put in one more value on it and see how it changes. So let's say I put 25 up here, so now as another value. I'm adding a value to it. So this is now 25. So that is the data now. I need to break it up, and I need to find the range, the interquartile range and the semi-interquartile range. The range is just 25 minus 1, right? Which is 24. We want to break it up first. So talk to me now. How many values are there this time?
Sir, 11, sir.
11.
Hold on a second. This thing jumping all over the place. 11 values. So since there are 11 values there, means that one of the values is the median, don't it?
Yes, sir.
Yes.
So you're going to have 5 below and 5 above. 1, 2, 3, 4, 5 below. And 1, 2, 3, 4, 5 above. So this time don't calculate the median. One of the values is the median. This becomes the median. That is your Q2. Agreed?
Agreed, sir.
Yes, sir.
And then now, since there are 5 values in this bottom half, we're going to get the median. What is the median?
3.
The 3. So that is what? Q what?
1.
Q1, sir.
Q1. And
Q1.
same thing up here. What's the middle of the top half? There are 5 values up here. So
19.
one value.
19.
19 becomes the top
Q3.
half. Q3. So then the interquartile range becomes Q3 minus Q1, which is 19 minus 3, which then
16.
becomes 16. And the semi-interquartile range is just the interquartile range over 2, because semi means half, which is now 16 over 2, which then is 8. Very good?
Yes, sir.
Yes, sir.
Let's do another one still. More maths equals better maths. So let's do another one still. Copy and paste it down here again. One more. Let's put this down here. So now a little bit smaller still. Put in one more value. It's okay. I'm gonna get 200. Huh?
What is it, sir?
No, not you guys. Maybe signature. Oh, she gets it already. I'm not comment. You call him? Yeah. You call him? Okay. Okay. All right. So ready now again. How many values there now?
Sir, 12, sir.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So since there are 12 values there, you know that we have to add a median to the middle, right? So we're going to divide 6 and 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So you divide 6 and 6. You have to add the median to the middle this time. You must always have a, so you're gonna add 9. The average of 8 and 10 is clearly 9. Value between 8 and 10 is 9. So Q2 is equal to 9. Then the bottom half has how many values? 2, 4, 6.
6.
Since there are 6 values in the bottom half, what we have to do?
Sir, I mean,
Sir, I don't
find
know.
the middle. Or the
Sir,
mean.
find the
We're gonna have the median. We're gonna have to find the average of these 2 middle ones now. See it?
Yes, sir.
So I have to put one in
4.
here,
Four.
average one in there. That is Q1. It's gonna be what?
4.
4, sir.
4. And the top half, I have to do the same thing, don't it? 2 middle
Yes.
values is this, don't it?
Yes, sir.
I'm gonna drop a value in between there. That's how much is that?
20.
20, sir.
20. So you see, there are occasions where you have to calculate averages 3 times. That's this example down here. This example, this previous example, we have to calculate, we didn't have to calculate any average at all. All the values could be used, where they're right in the table, could be used. In this example up here, we calculated average 1 time. And then the example we did over here on the slide, an example we did on the slide over here, we calculated average twice, once here and once there. So you see, it all depends on the number of values they get. You might have to calculate average 3 times, 2 times, 1 time, or none at all. It all depends on the number of values that they get. So you have to just work with the data in front of you. There's no set way to do it. There's no set, the way is set, and the approach that you use depends on the number of data that you get. So I give you all the possibilities, you know. I give you a possibility where you do have to calculate nothing. Wait, I'll give you a possibility you have to calculate all of them. You have to calculate the median 3 times. Right? 3 times you have to calculate the median. I give you an example here. You have to calculate, you didn't have to calculate the median at all. The value was there all the time that you could use. I gave you an example of here where we had to calculate the median once. And then on the slide over here, you have to calculate the median twice. So you see, you stick to the approach and work with the data that is in front of you. All right, good so far? Everybody good?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Let's start up by next door. Yeah. All right, guys. So the next thing we want to look at now before in the class are some statistical diagrams. All right. So that is raw data and not the standard deviation. We'll explain the standard deviation now. Boom, 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 boom. We'll explain it now. Maybe not. Let me not explain the standard deviation yet. Because the standard deviation is just an interpretation thing, right? And this is more like calculation and doing. So let me finish the diagrams first, and then when I decide if I do the standard deviation explanation, if I do it, I might just do it at the end of the class. But we can look at the diagrams that we have to do first. So statistical diagrams from raw data. Right? We're gonna look at some statistical diagrams that you can get from raw data. All right. So the first one is a bar chart, and it's mainly used for counting data, counting discrete data. Remember I spoke about counting data or continuous data? Because the counting data, the data is discrete. You have 10 of this, 5 of that, 20 of that, 15 of that. You can represent each data on a bar by itself. Right? You can represent each data on a bar by itself because you're counting. How many blue cars? 5. How many red cars? 16. How many yellow cars? 3. How many black cars? 4. You can represent each data on a bar by itself. So you put the red car them on one bar and you put a bar representing the number of red cars. You put a bar for the number of blue cars and you put how many blue cars you have. The number of bars on the yellow car, you put a bar for the yellow cars and you put how many cars, how many yellow cars you have. So because the data is discrete and you can count, you can represent each data on a bar by itself. But to make the data, to make the bar look nice and symmetrical, you usually make the bars be of the same thickness and the same distance between the bars. You want the bar chart to look kind of have some uniformity to it. Look orderly, not look random. So you make all the bars have the same thickness, and then the height of the bars now is what will represent the frequency of the bars. Another thing about when you join charts, frequency must always be on a vertical axis, generally speaking. Frequency must always be on your vertical axis. The thing with a bar chart is that you can have a horizontal bar chart, right? You can have a horizontal bar chart, where the frequency is on the horizontal axis. But for the most part, frequency must be on a vertical axis. One second. Hello?
Hello, good afternoon, Mr. Shaw.
Yes?
Yes, can I target your number? How are you?
Yeah, man, I have to talk to you. I'm in a class now, so I'm going to talk to you after first, please.
Oh, okay. You have a class later?
No, I'm finishing a class today, but I'll talk back to you afterwards.
All right.
All right, cool. All right. Sorry about that, students. Right. So as I'm saying, typically you put your bar chart so that the vertical axis is a frequency. All right. Put all the statistical graphs, frequency on the vertical axis. All right. But as I said now, bar chart is mainly used for discrete counting data. So it consists of vertical or horizontal bars. Rectangular bars have the same width and they are evenly spaced. The height or the length of the bars are proportional to the size of the data they represent. In other words, this is like the frequency, right? It's really like the frequency, but this is the only time you can maybe put your frequency axis horizontal. But for the most part, frequency is on a vertical axis. All right. So when in doubt, draw it so that the frequency is on a vertical axis. All right. So let's say we're representing the method of transportation of some persons. So you might have, when you do the survey, cars are taken by 320 persons. 320 persons use cars. Of 840 persons take the bus. And then other modes of transportation: walk, foot, ride bike, ride bicycle, fly plane, fly helicopter. Other persons, there are 1,560. You might want to represent this on a bar chart, because these are discrete data, counting data, and each of the items are separate from each other. You can represent each item on a bar. So you have a bar for cars, have a bar for bus, have a bar for others. All right, and so you can draw a vertical bar chart like that, or you can do a horizontal bar chart like that. Right, we put the frequency on horizontal axis, but this is the one that is most times used. 99% of the time, that's what you use. All right, sometimes on question paper, I wonder if it's that they cram for space, they use the vertical one, the horizontal bar chart. So the bars are horizontal, but majority of the time the bars are vertical. All right, so that's your bar chart. It's an example. Simple stuff. All right, the next piece of thing that we can have is a pie chart. Remember, I know the bar chart is when you want to show discrete data, and it's when the data, you have unrelated things, right, or different things in the data. All right, they're not connected really, they're separate things. All right, then we have pie chart. My question is, when do you mostly use a pie chart? You mainly use a pie chart when you want to show how a whole thing is divided into parts. Like a budget, like you have an amount of money. Like if, for example, you get your allowance or you get a salary. and you want to show how that salary is divided up among the things that you use the salary for. So you use the salary to pay a mortgage, to pay bills, for food, for savings, whatever. So you use a pie chart to see what proportion of the whole salary is used up for these things. You might be going, for example, to the supermarket, and you might categorize your food into 4 categories of food, right? Like you might have meats, you might have snacks, you might have juices, you know, you might have cooking stuff, you might have grown provision, I don't know. So you have this total money that you're spending. And so the amount that you're spending on each category of the food that you're buying at the supermarket, you can represent it on a pie chart. And the pie chart, what it does, it gives you a quick visual of how a whole thing is divided up. So by you looking at it, you can see what chunk, what takes up most of the thing, and what takes up the least amount of the thing, and what's in the middle, right? By looking at how large the sector of the things are, how small the sector for the things are. So remember, guys, a pie chart is mainly used to show how a whole is divided up. See, our whole is divided up into parts and how the parts relate to each other. That's when you use a pie chart, when you want to show how a whole is divided up into parts. All right. So this consists of a circle divided into sectors of varying sector angles. Each sector angle is proportional to the size of the data represented. So the sector angle, you have to calculate it because it must be in proportion to the data that it is representing, not a random thing. All right. I remember the total angle in the pie chart is 260 degrees, you know. So each sector, so this represents the total angle in the thing, and then that total angle relates now to the total of the data. Total of the data. And then each part now you divide it up. But you know, the best way to do it is with an example. So this is it. So in this example, I'm showing how a number of students divide up the subjects in terms of preference. All right. The number of students doing physics, who prefer physics, number of students who prefer chemistry, number of students who prefer math, number of students who prefer history, number of students who prefer English. And I want to show this on a pie chart. Huh?
English.
Yeah, English, like
No, English with physics there, sir.
No, you should be questioning math.
True, you know, true.
You should be questioning math. It's a math of a problem. Look here, math too low, 17. All right.
Sir, this
Math
look right to me, no, sir.
No.
No.
All right. Math should be like 30.
Yeah.
Math should be like 30. Math should be higher than all the figures on there. But anyway, that's what they present. This is Steven, all right. Math should be the top one. And physics second. Physics too low. How low physics is?
No, physics can stay where it is. Physics
No.
Physics can
No,
Physics
I'm not agreeing with you. Physics is the subject. Let me tell you about physics.
But sir, why English so high?
Listen to me. Because we naturally talk English. But listen to me, man. Physics is a subject that you can relate to because you can visualize what happens in physics. That's the beauty about physics. I don't know, people don't like physics, you know. Physics is a subject, is the science that you actually see these things in your real world every day. Chemistry, you don't see the things in chemistry, you don't see it every day. The things in biology, you don't see them every day as much. Not everything in biology. Some things in biology you see, but the things in biology, they're happening in abstract, they're happening behind the scenes, they are hidden. Physics, you can see the things happening. Something falling and bouncing off the ground. You put something in water, it floats or it sinks. You don't see the things happening in physics. You don't see
Yes,
the
sir, we
things.
see them in the sir, but we have to calculate everything behind them, sir, and I'm not a
But
fan
it is
of that.
based on, but but it is based on principles that are reasonable. Like, for example, energy. Energy cannot be created or destroyed. It cannot be converted from one form to another. So if something is at the top of a building, it has the potential to fall to the ground. So it has potential energy when it's at the top of the building. What's going to happen? When it falls to the ground, it loses that potential energy, but then it gains kinetic energy. So the potential energy that it had before is now converted into potential energy. That is assuming it don't lose any of its energy due to air resistance as it falls. And if it loses any of its energy as it falls, it is because it had to displace the air and give the air some of its energy. Why? Because it comes right back from the basic principle that energy cannot be created or destroyed, cannot be converted from one form to another. And when the thing falls and hits the ground and rebounds, it don't go back to the original height that it went back to. Why? Because it loses some of its energy. Why lose energy to it? It loses energy, some of its energy to the sound that it gave off. It loses energy because it maybe cracked the ground or put a dent in the ground. It takes energy to do those things.
Sir, that all of that what you just said
A
just
lot
sound
near roof,
a
sir.
lot for
Sir,
just a
sir,
ball
you have to
dropping
understand
from a
anything.
height.
Exactly. Some of that
But it
energy
makes
can
sense.
convert it to
But it
sound
makes
too.
sense and it's logical. It's logical and it comes from the premise that energy cannot be created or destroyed. It cannot be converted from one form to another form. So you lose energy to something else. And you can see the thing that you're losing to energy from something. Make a sound is the energy that you use to make sound, you know. So the ball fall on the ground and hit the ground and give off a sound. It lose some energy to the sound. Where it give off. The sound take some of the energy. If it crack the ground, it lose some of the energy to crack the ground. If you put a dent in the ground, it lose some of the energy to put a dent in the ground. So that is the reason why it don't go back to the original height. And if it falls in sand, if the thing falls in sand, it's gonna displace the sand and it's gonna stop. So it loses all its energy. It don't really lose energy, no, it transfers the energy to the sand. The sand did some work on the ball to consume the energy that it had. So the energy in the ball is transferred to the sand doing the work. So the sand applied a force to the ball and the ball traveled that distance in the sand and the work is force times the distance. So the force that the sand applied to the ball multiplied by the distance that the ball traveled is now equal to the energy that the ball had when it hit the ground or when it first hit the sand, because all the energy in the ball is now transferred into the work that the sand had to use to stop the ball and put the ball to stop, to rest. Because the ball non energy left. The energy is transferred to the work done by the sand.
So basically the sun is a thief. That's just it, you know, sir.
The sand is a what?
The sun is a thief. It get the energy from the ball, sir. It could have just remained there and leave the ball alone. Why the ball couldn't just roll away?
No,
just
because
roll away.
when the ball roll away, the energy gonna go somewhere else. Because if the ball roll away, then another form of energy sapping is gonna take place. Friction. The friction on the ground is gonna do some work to stop the ball. Once the ball stops, the only way the ball don't lose its energy. If the ball don't lose its energy, gonna keep moving forever and ever and ever, amen, and never stops. Once the ball change and stop, some force take place on the ball and do some work on the ball to stop it. Where you go again? Everybody continue in the state of motion, uniform motion in a straight line, unless compelled by some external force,
That's
to act otherwise. Everybody continues in its state of rest, meaning if it is stationary, it stays stationary. It will continue to remain stationary. Or if it is moving, it will move in a straight line. If it comes off a straight line and change in any way, it means that a force acted on it. And the force did some amount of work to change what it is doing. So whatever energy it had, if it don't have the energy and it moves, because it gained energy from a force. If it is moving and it has kinetic energy and it changes, because some force does some work on it to change it. Energy cannot be created or destroyed, it cannot be transferred from one form to another. And work is done when a force moves a certain distance, move anything a certain distance. Force times the distance where the force acts through is the work done. And the force and the distance is in the same direction. These things that you can see it, you can visualize it, it makes sense. Floating. A body will displace the same weight of a fluid in which it floats. So when the body is in equilibrium in a fluid, the upward thrust from the fluid is equal to the weight of the object in the fluid, right? And then now the weight, the weight of the fluid displaced is equal to the weight of the object. So based on the weight of the fluid displaced and the density of the fluid, you can then know the volume of fluid displaced, because density equal mass over volume. So all these things related, and you can see it, it makes sense. If you put something in a bath on a water and the thing weighs 100 kilograms, right? Then the 100 kilogram and the water is right at the rim of the bath. Then the amount of water that's going to flow out of the bath will measure 100 kilograms. But just that because it has a different density, the amount that comes out will be different. So if I convert now the weight, you put the mass and the density together to get the volume, but it is the weight that is displaces its own weight. But it's not because things have different density. Two things will have the same weight, depending on the density, will give you a different volume. We give a different volume because density is mass over volume. But the weight of the water that is displaced is equal to the weight of the object. So you work from the weight, and then from the weight to get to the mass. And you know that weight is mass times acceleration due to gravity. So therefore you can know the mass. And then density is called mass over volume. And so you do the mathematics that way so you can get the volume of water displaced based on the weight that you put in there initially. Everything connected. You can see it, you know, so the water will run over, and the amount of water run over have the same weight as the thing where you put in there. But just that them have different density, the volume is going to be different. That's all. Come on, man. Physics are the most natural subject. Physics. Because you can see it. When you talk about refraction, you look at the water, you see the something and refract, you see it. You see it and then you put the mathematics to it. When a light flow from one density into a space of another density, it goes through refraction. But it's something that you witness for yourself, therefore you can accept it. And like it, you know, see it. If you put a pencil in the water, the pencil like it bend in the water. So therefore, when you bring the mathematics to it now, you can see it because you see it yourself. So it's easy to appreciate. You just don't explain it with the mathematics behind it. And you put in the refractive index and all these things from one medium to the next. They talk about magnetic field and force and electricity and flux and all these things. And you do the experiment and you see it happening in front of you. And therefore you appreciate it. And you have the right hand rule and the left hand rule and all these things. And you can visualize your, that's the beauty about science, you know. They put you in a lab so that you can see it happen. So when you see it happen in the lab, you appreciate it a lot more, you appreciate it better, and you just know to bring the mathematics to it, to what you visualize happening. You put the mathematics around it, you wrap what you visualize and see in the lab, in reality, in real life. You wrap the mathematics around it, and you complete the circle. Physics is the most natural science there is, because we live it every day. We live it every day. We literally know what's going to happen to a ball when we throw it. We know what's going to happen. So therefore, them put some mathematics on it. You know, must can understand it. We're talking about like projectiles now. When you throw a ball, it's going to go up, have a horizontal flight, and it's going to come down. What that means? some vertical vectors taking place on it and some horizontal vectors taking place on it. Why? Because it goes up and across. So you can break the motion into two. You can break it into a vertical component and the horizontal component separately, and then they can combine them. And they have certain things that stays constant, something that is common to the vertical and the horizontal, like what? Like time of flight. The same time that it takes to go vertical up and down, is the same time it takes to go horizontal. Yes? Don't me talk about physics, you know.
Remember,
Sir, we
sir,
can now
remember
say
we're on side chart.
No, but I tell you, I just tell you that the mathematics, the physics is just natural science. It's the
we can
most
now say
natural science. Huh?
we can now say you love physics in a shade.
Yeah, man, because it's natural, it's very natural. Because you can see it happening. That's beautiful. You can't forget physics as long as you don't forget things in biology and chemistry. You can't forget things in physics because you live it and you see it happening every day in front of you. You just have to put the mathematics with it. But then no, it makes sense. Everything in it just makes sense. That's the beauty about physics. It makes sense because you see it happening. Right? So physics, man, I love physics. This tool low for physics, man. This tool, imagine the two best subjects, them are lowest subject them. Imagine that. Well, chemistry lower than maths, but them two subjects are not supposed to be low, man. A joke thing that them two subjects are too low. But anyway, back to the pie charts. You remember start talk about foolishness. So the first thing you want is the total. Remember, you know, you want a proportion of the total. You want to know what the proportion is of the total of each. But the proportion is represented by a fraction of the 360 degrees. So it comes back to our circular measure that we did the other day. Fraction of the 360 degrees. What fraction of 360 degrees is 10 out of the 90? Simple. So it's 10 over 90 times 360 degrees. So the sector that the 10 is going to take up is 10 out of the 90 times the 360 degrees. That is the size sector that the physics is going to take up. Simple as that. Right? So the sector angle is going to be that 10 out of the 90 times 360 degrees. And that's the same calculation right down the line. They're going to do 15 out of the 90 times 360 degrees for the second one. They're going to do 17 out of 90 times 360 degrees for the third one. You can calculate if you want. Then for the history, it's going to be 22 out of 90. I just put two of them on the slide. I can't fit all of them there. 22 out of the 90 times 360 degrees. That's the sector that is history is going to take up because it's 22 out of 90. You want to know what proportion is 22 out of 90 out of 360 degrees. So it's 22 out of 90 times 360. That tells you the angle that it will take up. And the last one was clearly 25 out of 90 times 360. And then all of these will therefore add up to 360. They will add up to 360. Simple as that. And then you're basically drawing a sector now, a circle, and then you're going to break it up into these sector angles. So how you do it now, step by step. Everything important. Let's look at the process. Everything important. Bam. You draw the circle, and they will tell you, they will more than likely tell you the radius of the circle that you must use. So they say do a 5 centimeter radius, you open your compass to 5 centimeters on the ruler, and then you draw the circle. You measure 5 centimeters on the ruler, the compass with a pencil, and you draw the circle so that it is 5 centimeters. If they want a 5 centimeters, sometimes it might be 4 centimeters. You draw it. So if it's a 5 centimeter, it's supposed to be 5 centimeters. And you draw your circle. Bam. From that center. Then what you do, you draw one line from the center to the circumference. You have to draw one random line. Draw one line from the center to the circumference to start. And then from that one line, we're going to start to measure your sector angles with your protractor. So if I put the line here, I'm going to put my protractor on the line like this. My protractor here, that's my protractor. I'm going to put my protractor on the line. I put the baseline on the protractor. The protractor is this. I put my protractor over it like that. Make sure so the base of the protractor pass through here. right here. Make sure the base of the protractor pass through and pass through 0. 0. And you put the baseline on the protractor, and you have the eye right here. Like this is the 90-degree line on the protractor, the 90-degree line. And I put that point right on the middle at the center. And you read 40 degrees up here for the first one. 40 degrees, you mark off 40 degrees up there, so. Then you move the protractor after you mark the 40 degrees, and you draw your line up there, right? So you measure it off and you draw the line, 40 degrees. But that's not what I just did on the thing. Just imagine it. You have to go and do it, you know. You go and do this one for me, you know. And then you're gonna go from this line now. Next one is now gonna be from this line. So you're gonna put the protractor on this line now. So you're gonna put it on the protractor. You're gonna put it on this way now. And this is the protractor now. You'll put it on that line. Because I'm now measuring now from here, from this line. So make sure the 0 pass through there, so. And you want 60 degrees. So you look, read from 0 up and you mark your 60 degrees somewhere, so. So you mark your 60 degrees somewhere, so. Mark it. And you move the protractor out the way. After you mark it up somewhere there, so, and you draw your line. Put in those and then you draw the line, 60 degrees. And you label that up, 60 degrees, and you put it in your chemistry. And then you put the protractor on this line again, on this line, you position it like this. Position the protractor, draw it in red. Position the protractor like this, put the baseline on this line. You want to pass through 0, make sure it pass through 0, yes, so. And the protractor gone over the thing like so. And you're looking for 68 degrees now. All right? So you look for your 68 degrees somewhere, so, for example. 68 degrees. You're reading from 0, come up to 68 degrees up there. So 68, you're looking for 68. And you mark it. And you move the protractor out the way. And you mark, you have a 68 degrees mark. And you draw your line up to there with your ruler. Well, I don't understand that. See there? You put in a 68 degrees by your pie chart, put in your math. That's too small, man. Math should have be like half of the thing, like run or so. Math should have be like road, run or so, man. All of this should have been maths. All of this should have been maths. Too small, man. A joke thing. But anyway, that's that. And then you want your 92 degrees next. So what you do? You measure your 92 degrees from this line, you know. So you put your protractor on this line again. Put it around here, so. Position it like that. Make sure that your 0 is down here. Passing through the line, 0. And looking for 92 degrees up here, so now looking for 92 degrees up here. So I'm going to go somewhere around here, so. 92 degrees. Looking for your 92 degrees on there, so somewhere. Right? You mark it. When you mark it, for this. Bam, you draw it. Draw the 92 degrees and you label it up 92 degrees. I don't have to do no measurement for the last one. The last one must be 100. You don't have to measure the last one. The last one in here must be 100. The last one right here, so must be 100. That's the last one. Right? And you label it up like that. That's your pie chart. That's a pie chart. And when you take a visual look at it, you see the biggest sector is the most popular one, and the smallest sector is the least popular one, which is wrong. Physics can never ever be least popular science and least popular subject. That don't make no sense. Physics have to up there with maths. Physics is a natural science, you know. You can see what is happening. Natural. Everything in physics almost you can see, visualize it. I did an experiment. When I did an experiment, you believe it, because you see it happen in front of your eyes. And you put the mathematics to it. Anyway. That's your pie chart. Then we have line graph. Line graph is very popular in businesses. We don't want to like measure performance from year to year, for example, or from month to month. What the line graph does, it shows upward and downward trends. And so they use a lot in business. So when you put a line graph, you can see if the business, say you're measuring profit or production, I measure production every year in a factory. I measure in sales, how much sales you have from year to year, you record it. And you put it on a chart. If you look at the numbers, just look at the numbers, you might not see what is really happening if you're just looking at the numbers. Now sometimes they're going up and down and the part is going up and down. But if you want to see if it is generally trending upwards over time, you put on a bar chart. Even people buying stocks and buying shares in companies, they want to see how the company is performing over a period of time. If you just look at the actual profit from year to year, you're not gonna, if you look at the numbers, you might not see in detail what is happening. But if you put it on a graph and look at it, you can see the graph is trending upwards, generally speaking, or trending downwards. So you can sort of project what's going to happen in the long run. That's how line graphs are important. They show upward and downward trend. And also, if you look at the lines and say some part of it is very steep, you know that there was a sharp increase. If you look kind of flat, you know that the increase wasn't so great. Because the line look kind of flat. So clearly you can see if it's sloped down, you know that it's a decrease. If it's slope up, it's an increase. We can also compare the increases. The lines that are sharp up, you know, so that's sharp increase. So you know that big increase that. But if you look kind of flat, you know, say it increase, but not increase so much, you know, it increase not so great. So the slope of the lines also help to, you can interpret the slope of the lines, the level, compare the level of increase or level of decreases. That's what a line graph does for you. It gives a visual of the upward and downward trend of anything. So it's usually used when you want to compare the same thing over time. That's when you use a line graph. Make a note of it. You use a line graph mainly when you want to compare performance over time. Performance, whether it is production, profit, losses, sales. Usually we want to see how something is trending over time. Whether the time is in months, or the time is in quarters, or the time is in years. That's when you use a line graph. A line graph usually have some time on the axis, x-axis, horizontal axis. And then the production or the profit or whatever it is on the vertical axis, and you connect the dots on it with straight lines from period to period with straight lines. And then you'll have to answer questions about the period, like which period has the greatest increase, which period there was a decrease, and also you might have to also make projections. What do you expect to happen in the following year? And we deal with questions like that, and I show you how you work them out and how you give the explanation. I'm going to show you those things later on, right? But for now, you see, it mainly shows upward and downward trends. And this is constructed by joining consecutive points on a straight line graph on a straight line. So this example here shows the ton of banana produced over a number of years. And those are the values, but just looking at the values, there are some up and down in there. We don't really see what is happening and how it is happening from period to period. If you put it on a line graph by just plotting the points, those are the points. Then after I plot the points, then you join them with straight lines. Don't put no curve on it. Straight lines, called a line graph. They put straight lines. So you can see that generally trending up, and then there was this period when there was a decrease, right here. And maybe that year there was some hurricane between 1990 and 1991, or some flooding, or some insects eat out the banana, or something. I don't know. Maybe they stopped the production that year for something. Like last year there was a pandemic. A lot of businesses are gonna see some downward trend for 2020 and 2021. A lot of businesses, if you look at some of the companies' trend graph in terms of the production or the profits, you're gonna see a lot of downward trend for 2020 and 2021. And then now as 2022 and 2023 go on, you're gonna see that the companies rebound and start to be profitable again. Some of them go back on the trend. So like you're going up, you reach here, so you get a decline. But from here to here, it's still up again. So it means that you make a nice rebound here, okay? Rebound better than the previous year. Some companies they rebound, but they rebound to a level like maybe here, so lower than the previous year. So they don't rebound fully. This one like a full rebound and gone past what they were before. So the upward trend that they had before, it literally, even though there was a decline here, they continue on that upward trend. So you can actually analyze it and say stuff like that, and then the trend even continues to increase there. Right? So there was this dip, but you know, it didn't affect the overall thing so much. So the trajectory continues up like that. Right? And then now, eventually I'm going to show you now how you project what's going to happen next. So we project what's going to happen next. One way to do it is to draw a straight line from the beginning to the end and extend that line. Extend that line, that same line, extend it to the next period so you can know what 1994 is going to be. So where this meet 1994, you read it over here to see what the production in 1994 would be. But we'll talk more about that in the next class. We'll do line graph proper. Right? We talk more about how you can project from a line graph to another year, and also do this same projection using a calculation method. Right? Using a calculation method. That's it. What time is it now? It's now
1:32.
All right, no problem. I stop it there today. I know I don't do much examples. Some of the examples that I did with the interquartile range and so on, it was good enough for now, right? So I wanted to watch over the video, and I think we're gonna maybe do some of these questions that I have on the screen here tomorrow. They are on the slide. The homework thing that I sent in the group. This thing that I sent in the group. So I'm gonna mark some of the questions that I might want you to do. You can maybe try in the meantime. Homework number 1. So see the question on homework number 1 here. Send me the questions on page 1, homework number 1. And some of the questions that they can maybe attempt to do. So see, for example, you can do some of these tomorrow. So the plan is, so this is a raw data question right here. Another raw data question right here. Right. This one is a pie chart question. See, pie chart. This one is a pie chart question. Right. This one also is a pie chart, I think. This one a pie chart. Another pie chart question. This one is. Right. This one is a line graph I spoke about. I'll do some of these questions tomorrow. Okay. That's what we're gonna do tomorrow. I'm not gonna rush this topic. We'll do some of these questions tomorrow. Right. This one is a histogram, but we're not a histogram. So we're not gonna be doing that one yet. This is for continuous data. So this one kind of place wrong. This question, leave out this question. Alright, that question kind of place wrong. So let me see. This is another trend question, line graph question. Right. Let me see the actual line graph. For this question, the actual line graph. See a line graph. See that? Ask for a line graph. And look at this part. So estimate cost of the plot of land in 1996. Give a date of the 1995. And I don't want us to estimate 1996. So when I look at how we do that tomorrow, just enter to you a while ago. To draw a straight line from the beginning to the end and extend it to the next period, 1996. And you read it across and the axis over there. That's how you do it, right? That's what you do by on a graph. So we're gonna look at these questions tomorrow, guys. That's the plan. If you like, you can attempt them first. At this stage, I still prefer sometimes for me to do the questions before you, and then you do them afterwards. But if you want to attempt some of these questions, you can go ahead. I'm gonna do tomorrow's class with some of these questions. And then we're gonna go on to ungrouped data and group data on Wednesday. So tomorrow is to practice some of these questions. Okay, Watch over the video. Go back at the details, everything important. Go back at the details of what we spoke about today. Everything is important. Right? And don't dislike physics. Whatever you do. Don't
Sir, I don't
dislike,
think that's possible, sir.
don't dislike physics.
I don't dislike it, sir. I just don't understand it, sir. That's different.
You need to let us speak more physics. Physics is a subject. Physics is a subject we can all talk and understand, you know, because it just makes sense. Physics.
No, man, sir, you can't talk and understand how to
Yeah,
It's
man,
like
can
a
talk.
language.
Don't me talk about it. Or me talk about the energy a while ago, and everything just makes sense.
Yeah, it makes
Sir,
sense,
that-
but at the
that
same
never
time, you have
reached
to
me,
be
no,
serious.
sir.
So
Huh?
that different Spanish come like physics come like Chinese.
Not joke, man. Make we start talk. We can take half an hour and talk of physics. I don't care about no physics in the class. Everybody did physics in this class. So let us speak physics for like a 10 minutes every now and then.
A bio and chemistry, Medina, sir.
Yes,
I
sir.
can
But
do physics, but it
Bio
never
is a
crossed my
different, bio
bed.
is a different grade of problem, man. Bio is
You leave out the best one, you leave out physics. You leave out physics, the best one.
Say, man, I really like physics, honestly, you know, say.
Huh?
Say, man, me and physics no good, you know, say.
So
He's
to be honest,
hold
I
on.
don't
Everybody quiet. Everybody quiet. Somebody who like physics, tell me.
Sir, I do it, but I don't like it.
Alright. Well, it's a love-hate relationship, sir. I love some of the topic them, but I just can't love all of it. No.
All right, that's
Yeah.
okay.
Sir, me do it, but me not like it. I like do the experiment them the easy, but the writing and the sir that hard.
Let me tell you, man. Key to physics is to realize and to connect it to the real life things that you see happening around you every day. That is the key to physics. To connect it with real life things. Just and the thing with physics, you can literally, when you read in the question, you know, in physics, you know, you can visualize it and you can almost imagine and see the thing happening.
So you sound like some Einstein thing you deal with.
No, man, no Einstein thing, man. You can't see the thing happening. When they say a man, push a box, listen, a man push a box up a ramp into the back of a truck. And them start asking some questions about it. The man push the box, he have to apply a force to the box. And the box move up a ramp, and the ramp is 5 meters long. So the man give the box some energy. The force when him push it with, and the distance when him push it. That's the energy when him give the box, you know. What happened to the box now? The box go up and go into the truck. So the box gain some potential energy. But when the box reach up into the truck, it stop. So now the kinetic energy just gain some potential energy. But the man give it an amount of energy, pushing it. But while he's pushing it, the ramp is giving some resistance. So some of the energy that he's pushing the box with, right? The ramp is taking it away with the resistance. So some of the energy is being lost through friction. But the box gains some potential energy. So the difference between the energy where the box gain in becoming elevated in the truck, between that energy and the energy where the man push it with, is the energy where they lose on the ramp. So the energy where they lose on the ramp is the same distance, it push over, you know, same distance, you know. So you can work out the resisting force, because the difference between the energy where the man put in the box and the energy where the box gain on the truck, the difference between those is the energy lost by friction on the ramp. And the energy is work same way, you know, which is force times distance, you know. So you know the distance where the friction work on the box. You know that distance, you know. And you know the energy where the box lose to that friction. So the force where the friction apply times the distance where you know equal the loss in energy between where the man put in the box and where the box reach up and up in the truck. So you can know the friction force easy like that. Common sense. You just make this logical. See there? Which are the situation I want to talk about? We want to talk about balance and force and moment. All right. You have a seesaw, or you have a bridge. You have a bridge. That's about balance now. Equilibrium. Common sense. It does make sense. You have a bridge. The bridge have two support on it. And the bridge go across the two support. Right? And you put a trailer up on the bridge and you drive the trailer up on the bridge. The bridge now moving or the bridge stationary, you know. So it means that all of the forces on the bridge balancing now. And also all the rotating forces on the bridge balance. What are the rotating forces? Moment. Moment is the effect of turning. So what happened? The moment balance because it not turn. So the vertical forces and the vertical forces up and down balance. What are the vertical forces? The resistance from the support acting upwards from the bridge. The weight of the bridge and the weight of the truck. Them four forces that balance. One over upon the left and one over upon the right. The weight of the truck acting down upon the bridge and the weight of the bridge itself pulling itself down. Those forces balance. The total weight of the truck with the goods and everything in it, the weight of the bridge, those acting down. The resistance from the two support on the bridge, keeping the bridge up, those forces balance. Then now the turning moments on the bridge also balance. The clockwise turning moment and the anti-clockwise turning moment balance.
Sir, please.
So you have some forces, and you have to hold on. You have to choose a pivot where you're going to choose turning about, right? So you choose either use the left pivot, the left hand of the bridge as a pivot, or the right hand of the bridge as a pivot. If you use the left hand of the bridge as a pivot, then the force through that one don't have no moment, because moment is force times perpendicular distance. The distance is 0. So the force through here so don't have no moment. So you eliminate that force right away from the calculations. So all the other forces now, you want to know the forces that will tend to turn the thing clockwise, turn the bridge clockwise, or turn the whole structure clockwise, and balance out that with all the other forces that will turn it anti-clockwise. You know the two forces going to turn it clockwise now. The bridge weight and the truck weight. So it's the weight of the truck and the distance from this fulcrum plus the weight of the bridge and the distance from that one. That gives the clockwise moment, total clockwise moment. And the anti-clockwise moment now is the force will act up on the next end of the bridge. So that distance times that force on the next way. That's a balancing equation. What that give you? That give you now you're able to calculate now the force, the resisting force on the bridge. And this one. Then you go back to the original equation where you balance the upward and the downward forces. That's another equation. So you have two unknown forces, you know. What are the two unknown forces? The two resisting forces from the bridge will balance at the bridge. You want to know what are the resisting forces from the bridge? Will keep the bridge up. You calculate one of them from the moment, and then you go back to the original equation and you calculate the next one. It's simple, makes sense, because the forces balance, the bridge stable, the bridge not moving. So all the forces balance and all the moments balance. Clockwise moment balance with anti-clockwise moment. Vertical forces balance with vertical forces up, balance force, vertical forces down. All the forces balance. Now the why not that hard if everything balance? Every force upward balance with all the forces downward, then equal. Clockwise moment balance with anti-clockwise moment because the bridge is stationary, it's not moving. That is moments. So you use moments. Which other topic you don't want to talk about? Which other topic you don't want to talk about? Who understand? We're speaking it. We're speaking it.
I just know that the point of turning, everything right there, so that equal to 0. That's all I know.
The moment at the point is 0. Because remember, moment is force times distance from the point. So the distance from the point is 0. So if you're taking moments at a point where there's a force, that force cannot give you any moment. The moment is 0 because the distance is 0. Things simple, man, or not complicated. Everything stationary, everything stationary, all the vertical forces up, balance with all the vertical forces down. And next thing, if you're pushing a box across a surface horizontally, then the weight now do not work, and the resistance on the floor now do not work. Why? Because work is force times distance in the same direction. So the box going across so, on a floor. The weight is down. So the weight now do not work. Because the weight not going horizontally. The resistance on the floor upwards, not doing any work either. Good? So those forces out, then balance each other.
Here, look like you have to start
and the vertical reaction from the floor balance each other. That's why the box stays stationary. If they never balance, the box will elevate or fall to the ground. If the weight of the box greater than the resistance on the ground, the box will fall to the ground. If the resistance on the ground greater than the weight of the box will float up. So from it stay horizontal on the surface and come up for the surface, the weight and the resistance balance. Common sense. That don't need no maths. That don't need no physics. That's just logical. Logical. If two men push each other, if you apply a force to a wall and you're pushing a wall, you're pushing against a wall, the wall not moving. The wall not moving. It means that the force where you push a wall with now don't work, even though you feel tired, but no work not take place. Because the wall move. In order for work to be done, the force have to move the object, move the wall. You consume energy in applying the force. Yeah. You understand? So, but anyway, guys, this is fun.
Sir, how much of the physics cost?
They will start teach physics.
How much, sir?
I'm not have time to teach physics. I don't have time.
General.
I don't have time to teach physics. But believe me, it's natural, But I don't have time to teach physics. I don't have the time because I teach maths every day. But logical, but if you need something, you can ask me 2 questions from now and then. You can ask me 2 questions if I can remember. That means a long time. I mean, I don't know the physics for maybe 30 years, I don't know physics, and I still remember those things. And Newton's laws of motion and all them. So I still remember them. I mean, I don't know physics for 30 years. Imagine that. 30 years. I don't know physics long before I was born. I can still remember the laws. Everybody continued in state of rest or uniform motion in a straight line unless compelled by some external force to act otherwise. The second one says, action and reaction are equal and opposite. The rate of change of momentum is proportional to applied force and takes place in the same direction in which the force acts. You just remember, anyway, there you go. You must learn the things them properly. When you learn the things them properly, they stay with you. They stay with you. And physics is good because you can see it every day in your life. So you don't forget it because you see it every day in your life and it just makes sense. Understand me? So don't sit there and think physics is difficult. At 30 years ago, I do physics. I still remember the things because they make sense. Not because I have good memory. It's just because they make sense. They're logical. The thing about physics, it can be logical. So don't sit there and think it's difficult, man. Open your minds and look at the reality of it. Connect it to real life. If you're connected to real life, it's easier. Connect it to what you see happening around you. If you start to talk about man push box in a truck, man push box up a hill, man push box across a floor, something falling from a height, just visualize it. Right? Something floating in something, electricity and magnetism put together to create a force, refractive index. Just all that. Those are the ones that I remember now at the top of my head. But I mean, almost anything you can see it. Work, power, and energy. Power is how fast it do work. That just makes sense. Work over time. That's what power is. When people say somebody powerful, it means that they can work fast. And you might be powerful. It means whatever you're doing, you do it faster than everybody else. The two persons do the same thing, but you do it faster. It means that you're more powerful. I do it quicker, take less time to do it. So power is the rate of which the rate of how fast the work, rate of doing work. That's what power is. So it makes sense. I can see it. When someone in real life, when somebody say, boy, a car is more powerful than a car. What it mean? It means that a car more powerful can go over the hill faster than a car when not as powerful. The more powerful car will go over the hill faster than the car that has less power. It means that the car that is more powerful does the same work in a shorter time. Does the same work in a shorter time. So you divide by a shorter time. So they do the work over a shorter time to get a higher power. That's it. Come on, man. The thing's simple, man. Stop making the thing complicated. You're telling no brain say it's hard. Stop doing that. You must stop doing that, man. Stop telling yourself that the things are hard. You defeat yourself when you do that sometimes. Because you tell yourself that it's difficult and it's not. Let me tell you, related to real life. Anything that you do, when it can be related to real life, and you're good. It's the body in the chemistry too, you know. Chemistry and biology. It's the body of them too, you know. But a piece of physics alone. You do what you have to do to learn them. All accounts, body and accounts same way. You do what you have to do to learn them. Physics is the one you can relate to real life. Chemistry, what I used to do to be good in chemistry, I used to read everything 5 times before I try the one question. Chemistry. That was me and chemistry. I read everything 5 times. If we're doing any topic we're doing in chemistry, I read it 5 times before I even try to do one question. Read it, read it, read it, read it. So by the time you read it the 5th time, you know exactly what it's gonna say. You know what it's gonna say. Anything you miss for the first 3 read or the first 4 read, you're gonna see it in the 4th read. And it stick. Chemistry is a subject that requires the most cue cards for me. I have to make a lot of cue cards to remember this stuff. Biology, diagrams. Just practice to draw the diagrams and label. Draw the diagrams. Practice. Draw the diagrams and out of your head and label them. Draw them and label them and explain each thing that you label. Biology. That is the key to biology. So every subject have a different approach. But they all can be conquered. All of them. All of them. In accounts, you understand the full cycle of the accounting and relate it to real life again. Full cycle of the accounting principle. Understand the accounting principle. We call it accounting cycle. We call it accounting cycle. Understand the accounting cycle. How the accounting process cycle. Right? How it go? From data entry right round and balance sheet come all the way back round final accounts. Understand that cycle and every step in the cycle and the double entry system and all of that. You conquer accounts and they have the processes in between. You can conquer accounts. All that subject them can conquer, man. Just find the right strategy for each one. Find the right strategy for each subject and conquer them. Especially maths. Maths are the softest of them all. Mathematics. Nicest and the softest of them all. All right, guys, that's it. Enough chatting. See you all tomorrow. This was fun. I really enjoyed this class today. We must have like a chit chat every now and then, same way. I'm really trying to see if we can start having some face-to-face. I don't really tie it down yet, but looking forward to doing that. All right. See what we can do. I have to do the face-to-face in a way where I still have to do some online because some persons might not be able to come to face-to-face. So I have to be able to pair the face-to-face with the online when that time comes. All right, guys. So see you all tomorrow. Have a great rest of the day. Bye, everybody.
Same to you, sir. Bye.
All right.
Yes, sir.
Don't dislike the physics. Develop a love affair of physics. All right. Bye.
Sir, remember to stop the recording.
Oh, gosh. I'm gonna stop it now. Ending the class now anyway. All right. Some messages here. All right. Bye, everybody.
Later, sir. Later, sir.
All right. Cool. Oh, God.